Welcome back to iOS Expert. In this video, I will introduce concepts that undergird a comprehensive unit test suite, namely dependency injection, test doubles, and append effects. Converter VC is a lot simpler now, but it's still not unit testable because it uses 5 APIs that are difficult to unit test. I described these APIs earlier when describing the files of Roman numerals, but here's a quick review. Device gets the name of the user's device and puts it in a user-facing message. Sound player plays a chime or sad trombone MP3 sound. Persistent storage saves results on and retrieves them from the device's file system. Analytics service sends analytics events to an imaginary analytics service when certain events take place in the app. Weather requester uses URL session to get the current weather conditions in Rome. I could just proceed to explain how to use dependency injection to make these APIs easy to unit test, but it's important for you to understand how these APIs make unit testing difficult in their current forms. To facilitate this understanding, I will show you some bogus unit tests, not using dependency injection, that don't work and/or that have undesirable side effects. Although these bogus unit tests are in the snippets file, don't copy or type them. They're just for illustration. Here's a bogus unit test for device. Just an assert that the value of user-facing message matches what was already displayed during previous runs of the app. Curiously, this unit test fails. Turns out that UIDevice.name, which device.userFacingMessage uses, returns a different value when running an app in the simulator and when running a unit test in the simulator. In the latter case, UIDevice.name has a value like clone 1 of iPhone SE 3rd generation. The value is also different when the unit test runs on an actual iPhone. In this case, the value is iPhone. Device.userFacingMessage is tricky to unit test because that API depends on something it has no control over, the value of UIDevice.name, which can vary. Whether SoundPlayer requires any unit tests is debatable because SoundPlayer is little more than a wrapper on AV Audio Player, which Apple is already unit testing. But SoundPlayer, which Converter uses in response to a successful or unsuccessful conversion, has a potentially annoying side effect, sound. SoundPlayer's side effect is potentially annoying because a unit test, unlike a user, derives no benefit from audio feedback. One could imagine a headless continuous integration machine startling nearby developers while running unit tests that invoke SoundPlayer directly or indirectly. Here are some bogus unit tests for persistent storage. Before I run these tests, I'll show you what's currently in the file system by running the app on my iPhone. Although unit tests often run in the simulator, the fact that an actual device more closely matches what users are running may make an actual device the appropriate host for unit tests in some instances. Note the save results. The unit tests for persistent storage seem straightforward. Save an empty string array. Verify that the retrieved array is empty. Save a non-empty array. Verify that the retrieved array equals the expected non-empty array. The tests pass. But there's a problem. The results that the user had saved on the iPhone by running the app have been replaced by results from the unit test. In other words, running the unit tests had the side effect of altering the contents of the iPhone's file system. If the user cared about conversions she had done in past runs of the app, this would be bad. There is also an uncontrolled dependency in that a unit test has no control over the initial contents of the file system. These analytic service tests seem to provide one of the benefits of unit testing, unit test coverage. But notice that there aren't any assertions. That is, these unit tests, if you can even call them that, verify nothing about the behavior of analytics service. They don't because analytics services' only behavior is to send analytics events to an imaginary analytics backend, and that behavior is difficult to verify in the context of a unit test. Difficult, but not impossible. In theory, the developer could use a tool like Charles Proxy to intercept and verify API calls by analytics service. Although requiring Charles Proxy might work in a day job context, coding challenge reviewers would likely balk at this sort of setup requirement for running your code. The quasi-unit tests on screen have another problem. Analytics service sends analytics events to an imaginary analytics backend. In a real app, this code would send analytics events to a real backend. But sending analytics events to a real backend would cost a company money and pollute user-generated analytics data with unit test-generated analytics data. When I created this bogus file, I happened to know that the current conditions in Rome were 52 degrees Fahrenheit, clear sky. The test initially worked, but it started failing 15 minutes later when the OpenWeather endpoint started reporting the temperature in Rome as 51 degrees Fahrenheit. Because this test involves a network request, it's slow, about 1 second compared to 6 milliseconds for a test like test height for row@, which doesn't hit the network. 1 second may not sound like a long time, but a production app could have hundreds of tests like this, so those seconds can add up. Finally, my internet connection is pretty reliable, but it's easy to imagine network failures on a continuous integration machine running unit tests for multiple pull requests at once. Here is a summary of the problems that these 5 APIs pose for unit testing. Device depends on the actual device that the unit test is running on, which can vary. Sound Player has the side effect of playing sounds, which can be undesirable. Persistent storage has the side effect of altering the contents of the device's file system, and the behavior of persistent storage depends on the contents of that file system. Analytics service has a side effect of potentially flooding the analytics backend with irrelevant analytics data. Also, validation that analytics events are firing at appropriate times is difficult. Weather Requester depends on the output of the OpenWeather endpoint and has the side effect of making the unit test suite slow. A note on terminology. I've been referring to dependencies that complicate unit testing and to side effects that are undesirable. One API, for example Weather Requester, can present both challenges. I propose one word, dependeffect, to encompass both. The novelty of this word, free of semantic baggage, is a recognition that not all dependencies complicate unit testing and that not all side effects are undesirable. A dependeffect is a special kind of dependency and/or side effect. Dependeffect is in the glossary for iOS Expert, but it's my word, so it's not on the certification exam. That said, I will use this word henceforth in this crash course and in iOS Expert. The production implementations of the 5 APIs in the chart I showed earlier share the same problem, dependeffects. In the early years of the 21st century, Gerard Meszaros developed, and Martin Fowler popularized, a solution for dependeffects, the test double. A test double is an object that replaces a production object for unit testing purposes. Test doubles lack the dependeffects that make production objects difficult or undesirable to use in unit tests. Here are the 5 kinds of test doubles that Meszaros and Fowler described. I'll show you the implementations of the first 4 kinds of test doubles later in this crash course. By way of preview, definitions of the first 4 types of test double are below this video. I won't discuss mocks in iOS Expert because I don't use them, and I've rarely encountered them in my day jobs. In order for consumers of dependeffects to have the flexibility to use production implementations in production, or test doubles in unit tests, dependeffects must be provided to consumers. In other words, consumers must give up the responsibility of acquiring or initializing their dependeffects. This practice of providing dependeffects to their consumers, rather than having consumers acquire or initialize their dependeffects, is called dependency injection, DI for short. Dependency injection comes in these 5 flavors, each with its own benefits, and in some cases, drawbacks. I'm not going to describe these flavors just yet. Instead, I'm going to create test doubles for the 5 dependeffects I described earlier and then use dependency injection to increase unit test coverage of Roman numerals. I will describe 3 of the dependency injection flavors as I do this. I will also say a few words about the 2 flavors that I didn't use. The first depend effect is device. Converter-VC calls the function user-facing-message to get a descriptive string that includes the device type, which Converter-VC puts on screen. The description of the device comes from uidevice.current.name, which, as I described earlier, complicates unit testing. The output of that API can vary, but consumers of device.user-facing-message don't actually care about implementation. They just need a property called user-facing-message. This need can be represented as a contract or, in Swift terms, a protocol. There can be 2 conformances to this protocol. One can have the existing implementation and be used in production by Converter-VC. The other, a test double, can provide a canned, consistent response for use in unit tests. A test double that provides a canned response for unit tests is called a stub. Here are the steps for creating the protocol, creating the production implementation, creating the test double, and using both. Replace the contents of device.swift with this code, snippet 21. This is the functionality contract. Note the protocol extension. I am a firm believer in don't repeat yourself. Both conformances to device, production and stub, will share the string Roman numerals is running on. To avoid repeating the string, I put it in a protocol extension. Now is the time to create the 2 conformances. Also in the helpers group, create files called device.stub.swift and devicereal.swift. Give devicereal.swift, which is the production conformance, these contents. Snippet 22. Like the original implementation, this one uses uidevice.current.name. But this implementation also uses message without device and placeholder from the protocol extension to avoid repetition. Next, open device.stub.swift, the test double. Give it these contents. Snippet 23. This stub has a name property, which means that unit tests can specify whatever device they want when initializing a device stub. An iPod Nano, for example. A quick aside on naming. My approach to naming depend effect protocols, production conformances, and test double conformances has varied over the years. I developed an approach while researching this crash course that I think maximizes clarity, and I'll use it going forward. Give the protocol the name of the original depend effect, in this case device. Give the production conformance the protocol name plus the word real. Give the test double conformance the protocol name plus the flavor of the test double, in this case stub. Naming is a little different for URL session.shared because that is an Apple API that can't be renamed. This approach to naming has 2 benefits. First, looking at file names tells code readers whether a conformance is for production or for unit testing. Second, the similar file names for a protocol and its 2 conformances mean that files sort near each other in the project navigator, speeding access to all 3. There is now a compilation error in Converter-VC. NodeView is trying to initialize device, now a protocol, rather than using an injected depend effect. Time to inject it. In the production code, SceneDelegate is a convenient place to initialize and inject depend effects, including the device real conformance of device. In SceneDelegate.swift, change the initialization of Converter-VC to this. Snippet 24. Ignore the build error for now. Injecting via the initializer like this is a flavor of dependency injection called constructor injection. Why constructor injection and not initializer injection, you ask? Concepts related to dependency injection were developed for Java and C#, which have constructors rather than initializers. This heritage means that many iOS developers use the term constructor injection, notwithstanding the technical absence of constructors from Swift. Go back to Converter VC. Add the following line to the top of that class's definition. Snippet 25. Change the signature of the initializer and add a line after the signature, as in snippet 26. Finally, change the line in load view that uses device to this. Snippet 27. Run the app to ensure that the injected device is working. Now is the time to unit test device. Create a helpers group in the unit tests group. In that group, create a unit test file called device_stub_tests.swift. Give the file these contents. Snippet 28. Unlike the bogus test I showed earlier, the success or failure of this unit test doesn't depend on the device that the unit test is running on. For the purpose of this unit test, the device is always an iPod Nano. That said, the production conformance can be safely unit tested to some extent. In the same group, create a unit test file called device_real_tests.swift. Give the file these contents. Snippet 29. This unit test doesn't test the complete output of user-facing message because the unit test doesn't know what device the unit test is running on. But this unit test does verify that the output starts with the expected string Roman numerals is running on. The second depend effect is sound player. Converter calls the function play to play a chime or sad trombone sound after a successful or unsuccessful conversion. As I described earlier, these sounds are a potentially annoying side effect during unit tests. This annoyance can be fixed by turning SoundPlayer into a protocol and using a test double conformance, in particular a dummy, during unit tests. A dummy is a kind of test double used when a unit test doesn't care about or need a real implementation. Unit tests of Converter not only don't need or care about a real SoundPlayer implementation, those unit tests affirmatively don't want one. SoundPlayer still needs a real implementation. That's currently in soundplayer.swift. Rename that file soundplayerreal.swift. Rename the class itself to soundplayerreal and add a conformance to SoundPlayer, the new soundplaying contract and protocol. That protocol doesn't exist yet, so create a Swift file in the same group called soundplayer.swift. Give the file these contents. Snippet 30. The test double is next. Create a file in the same group called soundplayerdummy.swift. Give it these contents. Snippet 31. Note the empty implementation. There is now a compilation error in Converter. .struct is trying to initialize SoundPlayer, now a protocol, rather than using an injected depend effect. Time to inject it. In this production app, this injection could happen in two places. It could happen in SceneDelegate, as with device. Or it could happen in Converter VC, which initializes the converter that actually needs a sound player. Here is the first approach, which I prefer because it means that depend effect initialization is confined to one place in the production app, SceneDelegate. In converter vc.swift, change the declaration of the converter property and add a sound player property, snippet 32. Change converter VC's initializer to this, snippet 33. Open converter.swift. Change the declaration of the sound player property to this, snippet 34. Open SceneDelegate.swift. Inject a sound player reel by changing the initialization of the converter VC to this, snippet 35. Run the app and ensure that sounds are still playing after conversions. Now is the time to unit test sound player. In the helpers group, in the unit tests group, create a unit test file called soundplayerdummytests.swift. Give the file these contents. Snippet 36. Note the lack of assertions. With no actual implementation, there is nothing to assert about SoundPlayer Dummy's behavior. This unit test is still useful, however, for its effect on unit test coverage. The whole point of treating SoundPlayer as a depend effect was to eliminate the sound side effect in unit tests of Converter. Open convertertests.swift. Fix the compilation errors by changing the initializations of Converter to snippet 37. Run converter tests. No sound. There is some value in unit testing SoundPlayer Reel. Although there is nothing to assert about its behavior, a unit test could potentially catch a new bug that would cause SoundPlayer Reel to crash. Create a unit test file called soundplayerreeltests.swift in the helpers group. Give the file these contents. Snippet 38. Note the lack of XCT asserts. The third depend effect is persistent storage. Converter VC calls the functions loadStringArray and persistStringArray to load results from and persist results to the device's file system. As I described earlier, persistent storage is a depend effect, difficult to unit test, because its behavior depends on the contents of a device's file system, and persistent storage has the side effect of altering those contents. This annoyance can be fixed by turning persistent storage into a protocol and using a test double conformance, in particular a fake, during unit tests. A fake is a kind of test double that has a real implementation, but that takes some sort of shortcut, for example using an array for storage rather than the file system. A unit test that uses this fake test double doesn't have any side effects and doesn't depend on anything except the contents of that array, which the unit test fully controls. Persistent storage still needs a real implementation. That's currently in persistentstorage.swift. Rename that file persistentstoragereal.swift. Rename the class itself to persistentstoragereal and add a conformance to persistent storage, the new persistent storage contract and protocol. That protocol doesn't exist yet, so create a Swift file in the same group called persistentstorage.swift. Give the file these contents. Snippet 39. The test double is next. Create a file in the same group called persistentstoragefake.swift and give it these contents. Snippet 40. Notice how this test double uses an array for storage rather than the file system. There is now a compilation error in converter-vc. Converter-vc is trying to initialize persistent storage, now a protocol, rather than using an injected dependeffect. Change the declaration of the persistent storage property to this, snippet 41. Add persistent storage as the last parameter of the initializer and set that property in the initializer. SceneDelegate is again a great place to inject a persistent storage real via constructor injection. In SceneDelegate.swift, change the initialization of converter-vc to this, snippet 42. Run the app to ensure that the injected persistent storage is working. Now is the time to unit test persistent storage. In the helpers group, in the unit tests group, create a unit test file called persistent-storage-fake-tests.swift. Give the file these contents. Snippet 43. Why the emoji, you ask? I use emoji in unit tests when I need string values, but the actual values don't matter, in order to make unit testing fun. Those emoji are like the bright colors on toothbrushes that dentists give to kids after cleaning their teeth. Unlike the bogus test I showed earlier, this unit test has no effect on the contents of the device's file system. Although persistent storage real is trickier to test, it actually can be tested safely. For the sake of unit test coverage, it should be tested. In the same group, create a unit test file called persistentstorage-real.swift. Give the file these contents. Snippet 44. The test function, test load and persist string array, is straightforward. Persist an empty array, assert that the file system is empty, persist an array with emoji, and assert that the file system has those emoji. But this test class has some wrinkles you haven't seen before. Here is another example of properties in test classes. These get initialized for every test function run and are useful for avoiding code duplication. A test class can override the setup function to perform work before every test function in the class runs. I used setup here to save whatever is in the file system in an array so that I could restore it later. There is also a class version of setup, not demonstrated in iOS Expert, that can be overridden. This function, if overridden, runs once before any test methods in an exe test case subclass. A test class can override the teardown function to perform work after every test function in the class runs. I used teardown here to restore the contents of the file system after the test function run, avoiding side effects. This isn't completely safe because the user's data can be lost if teardown somehow doesn't run, but in practice, this doesn't happen, and the data on a developer's device isn't all that valuable. These unit tests won't run on user devices. There is also a class version of teardown, not demonstrated in iOS Expert, that can be overridden. This function, if overridden, runs once after all test methods in an exe test case subclass have run. A one-to-one correspondence between functions in the app and test functions is common, but not always best. In this case, the operations of load string array and persist string array were so interrelated that I didn't see any point in testing them in separate functions. The fourth depend effect is analytics service. Converter VC, converter, and weather requester use this class to inform an imaginary analytics backend of converter view loading, conversion succeeding or failing, and weather requester failing or succeeding. In a real app, there would be a real analytics backend like Google Analytics, but analytics service just prints the event to the console. As I described earlier, analytics service is a depend effect, difficult to unit test, because this class has the side effect of polluting the analytics backend with events that have nothing to do with actual user behavior or experiences. Because tracking data about user behavior or experiences is the entire point of an analytics backend, this pollution is extremely undesirable. Analytics service has another problem with respect to unit testing. Unit tests of that class would ideally verify that analytics are being fired at appropriate times, for example after an unsuccessful conversion. But analytics service provides no facility for tracking what events were fired when. This side effect and this lack of facility can be fixed by turning analytics service into a protocol and using a test double conformance, in particular a SPI, during unit tests. A SPI is a kind of stub that also records some information based on how and when it was called. A unit test that uses this SPI test double doesn't have any side effects with respect to an analytics backend, but does record how it was called, allowing verification in the unit test. Analytics service still needs a real implementation. That's currently in analytics service.swift. Rename that file analytics service real.swift. Replace the file's contents with this, snippet 45. Note that the send analytics events function is no longer static because analytics service needs to be an injectable instance of a conformance. The protocol doesn't exist yet, so create a Swift file in the same group called analyticsservice.swift. Give the file these contents, snippet 46. The test double is next. Create a file in the same group called analyticsservice.spy.swift. Give it these contents, snippet 47. Notice how this test double uses this array to store analytics events for verification in unit tests. Three types use analytics service: converter VC, converter, and weather requester. Constructor injection works great for the first two. In SceneDelegate.Swift, change the initialization of converter VC to this. Snippet 48. Converter VC had been using static methods on Analytics Service, but instead needs to use instance methods on an instance of Analytics Service. In Converter VC, add snippet 49 after the declaration of persistent storage. Add the Analytics Service parameter to Converter VC's initializer and set the property. Change the initialization of converter to this. Snippet 50. Weather Requester also needs the injected Analytics Service. But constructor injection isn't the right choice because Weather Requester is stateless and doesn't have an initializer. Add the Analytics Service instance as a parameter in the getCurrentConditionsInRoam call, like so. Snippet 51. Injecting via the function call like this is a flavor of dependency injection called method injection. Time to modify Weather Requester so it can accept this parameter. In WeatherRequester.Swift, change the signature of getCurrentConditionsInRoam to this. Snippet 52. In Converter.Swift, add this as the second property in Converter so that Analytics Service can be injected into Converter. Snippet 53. Just one more step in the production code. In 9 places, the app is using a static method on Analytics Service, but needs to use an instance method on an instance of Analytics Service. In other words, the uppercase A needs to be a lowercase a. Fix this. Run the app to ensure that analytics are still firing. They are indeed. An existing unit test is now broken. In ConverterTests.Swift, change the initialization of converter in the two functions to this. Snippet 54. Unit testing is simpler for the Analytics Service depend effect because you only need to unit test the test double, Analytics Service SPY. You don't want to unit test Analytics Service real because you don't want bogus analytics events being sent to your analytics backend. In the helpers group, in the unit tests group, create a unit test file called Analytics Service SPY tests.swift. Give the file these contents. Snippet 55. This class is somewhat larger than other unit test classes I've shown you, and I'm not going to explain it line by line. My approach was to trigger each analytics event and verify, using the SPY test double, that the event was actually triggered. 2 observations about this class. 1. This async keyword allows the unit test to run an asynchronous function, getCurrentConditionsInRoam, without using a task. 2. Writing these unit tests revealed a bug in Roman numerals, demonstrating the value of unit testing, even in an app as small as this one. Here is the bug I found. In production, This function can be called in two scenarios. 1. The user types a decimal number and asks for it to be converted to Roman numerals. If this conversion fails, firing an analytic makes sense because the call is user-initiated. 2. Convert from Roman to decimal calls this function to check whether, for example, the decimal number 4 converts to II. It doesn't. Since that conversion fails, II is invalid input to convert from Roman to decimal, and conversion in that function must fail. In the second scenario, the call isn't user-initiated. Without user action, firing an analytic makes no sense. I didn't realize that I needed to avoid firing analytics in certain cases until I implemented analytics spy tests, and the analytics I was getting didn't match my expectations. The fifth and final depend effect is weather requester. Converter-VC calls the static function getCurrentConditions in Rome to get current weather conditions in Rome via URL session and the OpenWeather API. This is a depend effect for three reasons. First, the dependency on a backend whose responses are constantly changing, as the conditions in Rome do, makes asserting anything meaningful about those responses in a unit test impossible. Second, the API calls dependency on the device's networking stack and on an internet service provider makes unit tests potentially flaky. Third, the real API call makes running unit tests unacceptably slow, particularly in a larger app with many API calls to test. Confession time. Weather requester itself is not the cause of the depend effect. Rather, weather requester's use of URL session.shared is the cause. URL session.shared is a particular instance of URL session that uses the real networking stack and that performs real API calls. So the solution to the depend effect is not to make weather requester a protocol, as I did with the 4 other depend effects, but to use a stubbed instance of URL session to avoid using the networking stack and performing the real API call. This stubbed instance of URL session can quickly grab data from the app's bundle instead of performing the real API call. Because this data in the bundle never varies, unit tests run quickly and reliably. To implement this test double, URL session.stub, it is necessary to implement a new static property on URL session that is an instance of URL session. Given the OpenWeather URL, this instance gets JSON weather from the app bundle. Real talk here. This code is complicated. After reading about a variant of it in a Paul Hudson blog post in 2019, I didn't immediately grok the code, but it did and does work. I've used it in many apps in the ensuing years and indeed elsewhere in iOS Expert. I'll explain the code, but don't be alarmed if you don't immediately grok it either. Just use it if URL session is a depend effect in your coding challenge or production app. In the helpers group, create a Swift file called URL session extension.swift. Give the file these contents, ignoring compilation errors for now. Snippet 56. This is the new static instance of URL session, stub. In order for stub to do its magic, there needs to be an association between a URL, the OpenWeather URL for Rome, and a data object representing the contents of a JSON file in the app bundle. URL data dict represents this association. In Roman numerals, the dictionary will have exactly one URL key and one data value, but a more complicated app, needing to support many stubbed API calls, could have many URL keys and many data values in this dictionary. The dictionary needs to be populated exactly one time, the first time that the stub is accessed. The variable didProcessURL facilitates this. The implementation of the stub static property itself begins by populating the dictionary with JSON data from the bundle if didProcessURL is false. The data isn't actually in the bundle yet, but it will be soon. Finally, the implementation creates the new URL session instance using a special URL session initializer. This initializer takes an instance of a URL session configuration object that avoids using the networking stack, instead returning data from the bundle. The two lines before the URL session initialization set up this URL session configuration object. This setup requires use of another new type, URL protocol stub. Create a file in the helpers group called urlprotocolstub.swift. Give it these contents. Snippet 57. Most of the code in URL protocol stub is boilerplate required of any type that conforms to URL protocol, as URL protocol stub must. The magic occurs in start loading. In this function, the pre-existing association between the OpenWeather URL and data in the bundle results in that data being returned to stub clients. There is error handling code, but it never runs because the URL is always good and the association always exists. For error handling to become relevant, there would need to be a bad URL, which is certainly possible from a testing perspective. Time to put some mock data in the bundle. Create a top-level group called mock data. In that group, create a file of type empty called currentconditions.json. Give the file these contents. Snippet 58. There is one remaining error in URL session extension.swift. This file uses a helper to avoid repeating a string error message about URL initialization failing. In the helpers group, create a Swift file called urlextension.swift. Give it these contents. Snippet 59. This implementation is so straightforward that I won't comment on it except to say that I take the dry, or don't repeat yourself, principle seriously. Time to use constructor injection to inject URL session.shared into converter VC, and to use method injection to inject URL session.shared into weather requester. Open scenedelegate.swift. Change the initialization of converter VC to this. Snippet 60. Open convertervc.swift. Add this property to converter VC just below the analytics service property. Snippet 61. Add session to converter VC's initializers parameter list and initialize the property. Scroll down to the fetch conditions function. Change the if-let line to this. Snippet 62. Time to modify weather requester so it can accept and use the injected URL session. Open weatherrequester.swift. Change the signature of get current conditions in Rome to this. Snippet 63. In that function, change URL session.shared to session. Run the app to make sure the OpenWeather API call is still working. That is some lovely weather. You can't run unit tests now because there are errors in analytics service by tests.swift. Open that file. Add a comma and this line to the initialization of converter VC. Snippet 64. Change the call to get current conditions in Rome to this. Snippet 65. This unit test will run faster because converter VC won't hit the network for its API call, but rather use the JSON data in the bundle. You can now create a fast-running unit test for Weather Requester. Create a unit test file in the same group called Weather Requester tests.swift. Give it these contents. Snippet 66. Run this unit test. Fast, right? I said earlier that 100% unit test coverage is difficult to achieve. Here are a few examples of that. This is Weather Requester. To test this line, I would have to simulate not having set up an API key. This would add considerable complexity in return for, in my view, little value. This line is uncovered by unit tests, but I'm not going to bother because this line will never run. The URL is always valid. I could have just force unwrapped the URL here, but did not for two reasons. First, force unwrapping is controversial with some developers, and I generally avoid controversy, except with respect to my non-use of interface builder and test-driven development. Second, the fatal error, with descriptive message, documents my expectation that the unwrap will succeed more explicitly than a lonely exclamation point would do. Converter VC is ready for unit testing. Create Converter VC tests in a new controller group. Give the file these initial contents. Snippet 67. There is some untested code with fatal errors that is untestable because running those lines in a unit test would cause unit testing to end. Here is some good news. Other unit tests are already covering three functions in Converter VC: the initializer, load view, and fetch conditions. There are obviously no explicit assertions about the behaviors of those functions, but I'm not going to bother creating unit tests for them because the fact that the app runs and shows the Converter VC UI is already a clear demonstration that these functions are working as intended. There are 4 completely untested functions. For the sakes of behavior verification and unit test coverage, these functions should be unit tested. The runtime calls convert and update UI decimal to Roman or convert and update UI Roman to decimal after the user types in one of the 2 text fields and the user taps the corresponding convert button or the user taps the return button. To avoid code duplication, these 2 functions call the private function convert and update UI with different arguments. All 3 functions are about performing the conversion and updating the UI accordingly. The runtime calls clear results when the user taps the clear results button. This function clears results from the converter data source model and persists the new, empty set of results to persistent storage. Go back to Converter VC tests. Add the following property, setup function, and test functions. Snippet 68. All test functions in the file need an initialized Converter VC. Declaring this as a property and initializing it in setup avoids code duplication. Implicitly unwrapped optionals are generally disfavored by Swift developers. Properties in unit tests, like this one, are a widespread exception to this disfavoring. If the property were optional, rather than an implicitly unwrapped optional, any use of the property would require careful unwrapping. Desire to avoid the boilerplate associated with this unwrapping explains, I believe, the widespread acceptance of implicitly unwrapped optional properties in unit tests. I won't explain every line in these 2 unit tests. Instead, I'll just say that they verify that the 2 internal functions whose names start with convert and update UI have the expected effects with respect to both the model and UI. Note the build errors. The Converter VC's model, an array of strings held by its converter data source, is currently inaccessible because the converter data source is private. Open Converter VC. Change the access level of converter data source to internal. Go back to Converter VC tests. This brings up a trade-off I often see in unit testing. The goal of comprehensive unit testing is sometimes in tension with the goal of maximal encapsulation. When writing unit tests, I often find it necessary to break encapsulation by changing a property or function from private to internal. There are still two build errors caused by the fact that Converter View is private to Converter VC. Change the access level of Converter View to internal. Time to test clear results. Add this function at the end of Converter VC tests. Snippet 69. This function verifies that the function called by tapping the Clear Results button has the expected effect of clearing the results array in the converter data source model. With the help of Dependeffects, both the helpers and main screen of the app, powered by Converter VC, are now well unit tested. In the next video, I will propose unit tests for some other files and introduce a tidier approach to dependency injection. I will also share an opinion about a subject that is much debated in the iOS development community.